All right, guys, we are finishing, or we're going to continue with our statistics unit. So today we're going to talk about different types of patterns that we see in graphs, which include shape, center, spread, and we're going to figure out mathematically how to determine whether we have an outlier. Up until this point, we've kind of guessed, oh, this number is far away from the other data, so it's probably an outlier. But today I'm going to show you mathematically how to figure out if you actually have an outlier. So when you look at graphs, so here we have a histogram at the top, then we have a dot plot, and then we have a box and whisker plot. So these all show symmetrical shapes. So obviously, if something has symmetry, it's like a mirror image. So you need to recognize whether a graph is symmetrical or if it has skew, which we talked a little bit about last week. If you kind of think of the design of a graph and if it's not symmetrical, if it's not symmetrical, it either is going to skew right or skew left. So if you follow this down, you kind of think of this as a tail that kind of goes off to the right. So this skews right. The majority of the data is concentrated over here to the left. So this shows that it skews right. This also has a majority of the data on the left side. So this one skews right and this one as well. So if you think of your median, whichever part has the longer tail, or in other words, from the median to either the upper value, this would skew right, or on the next page, these are all examples of skewed left. So if you follow the design, this kind of runs off down to the left, the dot plot, and the box and whisker plot as well. And we talked about that last week as well. All right, so if you're talking about the center of your data, normally that has either to do with the mean or the median. So if you have a symmetrical graph, probably the mean and the median are going to match, or they're going to be very, very, very close. So if you have a symmetrical graph, those two quantities should be very, very close or match. However, if you have a graph that skews right, that means that the mean is going to be greater than the median. And then the opposite is true. If you have a graph that skews left, that means the mean is going to be less than the median. So if you have a graph that's symmetrical, when it asks for the middle of the data, you're going to use the mean. If you have an outlier, however, the best description of the center is going to be the median. Now also shape, you have a uniform. If you have a graph that is, exactly the same, there's no high points or low points, you would say that that is uniform, like the picture of this histogram here. If you have a dot plot and all of the numbers have exactly 2 dots or 2 X's, you would say that that is uniform. All right, so let's look at all these graphs, and I want you to think before I say the answer, what shape are these graphs? So the first one, you would say that this skews in which direction? To the right. What about number 2? This has a skew to the right. So this is from here to here, that's 50% of your data. From the median to the lower quartile, that's 50% of your data. So this tail would kind of skew off to the right. All right, what about number 3? You would say this skews left. Number 4, same thing, this skews down to the left. Hopefully you're getting these correct when you're thinking these on your own. Number 5, we would say that that is almost symmetrical. Not exactly, but it's more symmetrical than has a skew. All right, what about 6? You would say that this graph skews right. Number 7, this dot plot skews left. And number 8, we would say that this graph looks very symmetrical, right? symmetrical. So I hope you guys identified those. All right, so I kind of said this earlier, but the measures of center will be the mean or the median. You must graph the data and decide on the shape before you talk about the center. If the data is skewed, the center will be the median, which is the middle number once you put the data in order. If the data is symmetrical, the center will be the mean, and all the data points, you will add up all the data points and divide by the number of data points. And I said earlier, if the data is symmetrical, probably the mean and the median are going to match. They should. All right, so let's try making a dot plot, and then we're going to determine whether we're going to use the mean or the median. So we're going to start with our number lines. Let me change this to yellow. We're going to start with a number line. I see the smallest number 0, the biggest number 7. 0, 1, 2, 3, 4, 5, 6, 7. And we're just going to put X's in order of what we see. So I have 2, 1, 2, 3, 1, 2, 1, 2, 1, 0, 2, 1, 0, 2. And then I have 7, 5, 3, 7, 5, 3, 1, 1, 1. 2, 6, and then I have 3, 2, 0, 3, 2, 0, 4, 1, 1, 4, 1, 1, and then 3, 1. All right, so we can tell this is obviously not symmetrical, so it skews to the right. So would we use the mean or the median? Well, since it's not symmetrical, we would talk about the center, we would talk about the median, right? Because this would skew to the right. So we would talk about the median. All right, what about this one? Let's try that. I think the spacing messed up, so this shouldn't be a 21 or a 62. It should be a 2 and a 2, 1, and then on the bottom is a 6 and a 2. All right, so I see the numbers from 0 to 8. 1, 2, 3, 4, 5, 6, 7, 8. All right, let's do this. 2, 2, 3, 4, 8, 1, 2, 1, 1, 2, 2, 1, 5, 2, 2, 3, 2, 0, 3, 6, 2, 3, 3, 3, 2. Once again, this is not symmetrical. So this time we're going to use the median again, right? Now, if we didn't have these points right here, let's say we did not have 5 through 8, we didn't have those 3 points, then we would say that this is almost symmetrical. There's one more X over the 3 than 1. But if we didn't have these right here, we would use the mean, right? However, the way it's drawn, since it does skew right, we would use the median to find the center. All right, you guys try number 1. Pause the video, try number 1, and then come back and check your answer. All right, so I did this one earlier, and when I drew it, I found out that this is exactly symmetrical. Hopefully that's what you saw in your picture, and that means that you would use the mean to talk about the center of the data. All right, if you have any questions about that, let me know. All right, so now we're going to talk about spread. So when we're talking about spread, we want to know how varied our data is, and we talked about that last week a little bit when we talked about the mean absolute deviation. So both of these histograms show symmetrical data. If you notice, though, the spread on the left is less than the spread on the right. So, you know, that's not neither a good nor bad thing. But when you're talking about, you know, making decisions or describing, you know, specific data, you are interested in how spread out your data is. So the spread also depends on the shape of the graph. If the graph is skewed, you're going to say that the spread is based on the interquartile range instead of the regular range, right? So to find the range, you subtract the smallest number from the biggest number. But if you have a skewed graph, you need to rely more on the interquartile range. So that's where you take the lower quartile, which is Q1, and you subtract it from the upper quartile, which we can also call Q3. And also, remember last week we talked about the mean absolute deviation. So if you have a graph that's symmetrical, if you talk about the spread, we can also talk about the mean absolute deviation. But if it's skewed, you only want to talk about the interquartile range. All right, so we can put these numbers in order and figure out the median, the lower quartile, and the upper quartile. Let's do that real quick. And then I'm going to remind you last week that I showed you how to use a calculator to do this. Remember? All right, so the first thing we would do is put these in numerical order. So our smallest number is 12, and then 14, and then what, 19 maybe? And then 20, I see a 24, I see a 26 and a 27. So I got 20, 24, 26, 27. Now what, 32 32s? 32, 32, 33. Oh, I wanted these on the same line, but I'm running out of space. I have two 40s. So I have 43, 46, 43, 46, and then we have 51, 52, 55, and 74. All right, so what do you do when you finish copying? You always count how many data pieces you have. So we have 2, 4, 6, 8, 10, 12, 14, 16. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So first thing I'm going to do is find out where the middle is. So I have 8 and 8. 1, 2, 3, 4, 5, 6, 7, 8. All right, and now I have 8 upper numbers. So my median is 32, right? Well, now I have 8 smaller numbers and 8 big numbers. So the middle of the lower numbers, 1, 2, 3, 4, 1, 2, 3, 4. All right, so my lower quartile, or quartile 1, is the average of 20 and 24, 21, 22, 23. So 22. Did y'all just see me count on my fingers? Oh my goodness. So my lower quartile's 22. And then what comes halfway between 46? I do that so I can see the middle number. So I do 46, 47, 48, 49, 50, 46, 47, 48, 49. So 40, or I could of course add them and divide by 2. So 49 is my upper quartile, or quartile 3, right? So now finally, the interquartile range is 49 minus 22. So the interquartile range is 27. 27, okay? So hopefully you got that too. All right, now we're going to practice finding the mean absolute deviation. And we did that last week. So do you remember step 1? Oh, I erased my answer. No, I didn't. So we found out the interquartile range is 27. All right, now we're going to figure out what the mean absolute deviation is. All right, so step 1 is to find the mean. So let me find my calculator. So you guys do it with me. Make sure I don't make any mistakes, which I'm very prone to do. 74 plus 32 plus 12 plus 14 plus 52 plus 33 plus 26 plus 24 plus 27, 55, 43, 46, 51, 32, 19, and 20. All right, so we had 2, 4, 6, 8, 10, 12, 14, 15, 16 divided 5. I'm dividing 560 by 16. Yeah, and I got 35. So the mean is 35. So do you remember what to do now? Now we find the difference between the mean and each data set. So 74 minus 35 is 39. 32 from 35 is 3. 35 minus 12 is 23. And then that would be 21. And then 52 minus 35 is 17. And then 33 from 35 is 2. And then 35 minus 26 is 9. 24 from 35 is 11. 35 minus 27 is 8. 55 minus 35 is 20. 43 minus 35 is 8. 46 minus 35 is 11. 51 minus 35 is 16. That was 51, right? 35 minus 32 is 3. 35 minus 19 is 16. And 20 from 35 is 15. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. All right, so now we're going to find the mean of our differences. Two plus 9, 11 plus 8 plus 20. Are you guys doing this with me, or are you just watching me work? Plus 3 plus 16 plus 15. I got a total of 222. 222, and we're going to divide that by 16. And I got 13.875. And what was our interquartile range? It was 27. All right, so we would want to know, okay, do we have, is this skewed? Because remember from 2 slides ago, if the graph is skewed, of course we didn't graph it, but if the graph was skewed and we're talking about spread, we would want to talk about the interquartile range. But if it's symmetrical, we would want to talk about the mean absolute deviation. Okay, so I would need to graph that first. I don't want this video to be 2 hours. So anyway, now you remember how to find each of those things. All right, so do y'all remember how to use your calculators to find this information? So let's review that real quick. So you're going to hit the data button. So first of all, clear your calculator, hit clear and on at the same time. Hit your data button, and then we're going to type in all these numbers. So we got 23, enter, 45, enter, 65, enter, 24, 16, 32, 42, and 34. And then you hit the second button and data again. And then enter 3 more times, 1, 2, 3. And then you scroll down and we want the interquartile range. So we want the Q1, which is, so Q1 is 23.5, and we want Q3, which is 43.5. And then to find the interquartile range, you subtract those two numbers, 43.5 minus 23.5. And the interquartile range is 20. Okie doke. All right, and then you guys have 2 more sets to do of that. You can either do it by hand, you can put them in order, find the middle number, then based on that, find the lower quartile, the upper quartiles, and then subtract those 2 numbers, or you can use your calculator. Okay, so you guys try those. The third one, the try this number 2, I did do earlier, and I got The lower quartile is 56. The upper quartile is 88. So the inner quartile range is 33. So just practice a few of those, okay? All right, so example 2 wants us to figure out the spread of the data. And then we're going to look for outliers. All right, so I do want to go ahead and graph this. And then we're going to talk about outliers. All right, so do I want to do a box plot? Or do I want to do a dot plot? Let me think for a second. Let's go ahead and do a box and whisker plot. Okay, so for a box and whisker plot, we need to order the numbers from least to greatest. So I'm going to do 0, 0, 0, 0. And then how many ones do I have? I have 1, 2, 3, 4, 5, 6, 7, 8, 9 ones. 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. And then we have twos. We have 1, 2, 3, 4, 5, 6 twos. 1, 2, 3, 4, 5, 6. And then we have 1, 2, 3, 4. 1, 2, 3, 4 threes. And then I see a 5. So I have a 5. I have 1, 6, and a 7. All right, so let's see how many numbers we started with. We have 1, 2, 3, 4, 5, 6, 7, 8 times 3 is 24 plus 1, 25. Make sure I have 25 numbers. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. You gotta be kidding me. Oh, there's another 4. Did you see that one? Or there is a 4. I missed that totally. So 4, 5, 6, 7. 4, 5, 6, 7. Y'all probably saw that. I have no doubt. 4, 5, 6, 7. All right, so 25. So that means I have one middle number. So that would be number 13. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. And then I have 12 higher numbers, right? So that is the median. The lower quartile is 1, obviously. And then the upper quartile is 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5. Wait, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 1, 2, 3, 4, 5, 6. Okay, anyway, it's not this number, but it would be between 3 and the next number, which is a 3. So the upper quartile is 3. The lower quartile is 1. And so that means the inner quartile range is 3 minus 1 equals 2. So the inner quartile range is 2. So I am going to jot this down so now we can make our box and whisker plot. So Q1 is 1, Q3 is 3, and our median is 2. All right, I'm gonna get rid of all this stuff, you guys. Bear with me. Hopefully you're going along with me. You're not just watching me. All right, so we would do our box and whisker plot by making a number line from 0 to 7. So 0, 1, 2, 3, 4, 5, 6, 7. Our box goes from our lower quartile to our upper quartile, which is from 1 to 3. Ignore that line. I don't know why my pen does that. From 1 to 3, and then dang it. And then the line in the box points toward the median, which is a 2. And then pretend this stupid line's not here. Will it let me do my left whisker? So my smallest number is 0, right? And my highest number, oh my gosh, look at what I did. This is a 7. And then my right whisker goes all the way up to 7, okay? So this definitely skews to the right. So it looks like 7 is an outlier, okay? So now we're going to figure out mathematically how to determine whether or not it is. So let's go to the next page. The question is, are there any outliers? To check for outliers, these are the steps. This is what you can always do to figure out if there is technically an outlier. The first thing we're going to do is calculate the interquartile range, which we did. So we know the upper quartile Q3 is 3 and Q1 is 1. So we know our interquartile range is 2. So we're going to multiply 2 times 1.5. It's always 1.5, all right? So 2 times 1.5 is 3. And then the next step is, after you do that, you're going to subtract Q1 from 3. The interquartile range times 1.5 is 3. Obviously, you multiply before you can subtract. So we're going to think, what is 1 minus 3? So 1 minus 3 is -2. So if we had anything in our data less than -2, that would be an outlier. Well, we don't. So we don't have an outlier that is in the low section of our data. So now let's figure out if there's a higher number that's an outlier. So which we assume is probably 7, but we're going to figure out for sure if it is. So now the other step is, we've already done this. Do this first. Interquartile range times 1.5, which is 2. Now you take your Q3 and you add it to that number. So our Q3 was 3. So when we add 3 plus 3, we get 6. And then it says if there's anything in your data set above 6, in this case, it is an outlier. So we had one, right? 7 is definitely an outlier. So that's how you figure out mathematically if you have an outlier or not. And you guys are going to have to remember that, okay? So when you're doing your quiz this week and your test eventually, you're going to have to figure out mathematically if you have an outlier. Because if you do, and it's asking about center, if you have an outlier, you have to use the median. If there isn't an outlier, you're going to rely on the mean. All right? All right, so we're going to try this one. Are there any outliers? We're going to make a box and whisker plot to see if there looks like there's one, and then we're going to calculate to see for sure if we get one or not. Okay, so we're going to put these in numerical order first. All right, so our smallest number is 49. Our next number is what? We have two 65s. 65, 65. 66, 68, 70, 74, 78, and 79. All right, 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3. So our middle number is 68. That's our median. Our Q1 is 65. And our Q2 is 76, or Q3, I should say. 76, 65. So our interquartile range is 76 minus 65, which is 11. Now the data is not your number line. I had kids every year, they want to put their box and whisker plot on their data, and then they go, oh, it's 100% symmetrical. Well, of course it is if you use your data. Don't use your data, you have to make a number line, okay? So from 49 to 79, why don't we count by, we'll count by twos, I guess. We'll do 48, 50, 52, 54, 56, 58, 60, 62. Oh, my number line is going to be way too short. 66, 68, 70, 72. Oh, man. 74, 76, 78. Pretend there's, okay. Oh, I squeezed it in there. Pretend those are 76, 78. All right, so our box goes from 65 to 76. So there's 76. Here's 65. The line that goes through your box is the median. In this case, it's a 68. We have our upper quartile all the way up here to 79. And then look at this, our lower quartile, woo-wee. So does it look like we have an outlier? It certainly does. It looks like 49 is definitely an outlier. It skews our data to the left. All right, so we think the answer is yes, but let's figure out mathematically. All right, let me get rid of some of this stuff. Go away, go away. My eraser's not erasing. There we go. All right, now do you remember the steps? Where you take our interquartile range and we multiply it by 1.5. So our interquartile range was, what was it again? 76 minus 65. Our interquartile range is 11, and we multiply 11 times 1.5. So 11 times 1.5, 11 times 1.5 is 16.5. So then we take our lower quartile and we subtract. So our lower quartile is 65. We subtract 16.5 from it. 65 minus 16.5, and the answer is 48.5. Woo! So remember the rule, if it's below, if you have a number below that number, 49.5, you have an outlier. Well, our lowest number was 49. So is 49 below 48.5? No. So amazingly, 49 is not a outlier. It looks like it is, but it isn't. We just proved mathematically that it's not. And then if we did the same thing, if we took our upper quartile, which is 76, and we add it to 16.5, 76 plus 16.5, that's 92.5. Well, do we have a number above 92? No, we don't. So we don't have an outlier above our data. So the answer is a little surprising, isn't it? All right, so this confirms what I just said. There are no data points below 48.5, even though it's very close. So there's no outlier on the low end or the high end. All right, so now there's a step B. I want you guys to pause the video. I want you to do those steps. I want you to find the interquartile range, identify the lower quartile, the upper quartile, and then I want you to prove, and first of all, I do want you to make a box plot for practice. And then I want you to prove mathematically whether you have an outlier or not. So don't forget those rules. And then on the next slide, after you do that, I want you to check your answer, which is on the next slide. All right, did you guys do it? Okay, let's check your answer. There's no lower quartile, there's no lower outlier because you had no data points below 38.75. Hopefully that's the number you guys came up with. But what about the upper numbers? There was an outlier, right? You should have figured out you can't go over 72.75, but the highest number is 78. So you guys do have an outlier to the high end. Okay, how'd you guys do? All right, so I want you guys to try these. You're gonna follow the steps that we just practiced, and you're going to figure out if you do have outliers. And look at this sentence, you may be surprised. So sometimes it looks like you definitely have an outlier, but once you do the math, you'll figure out that there isn't. Okay. All right. I'm going to let you guys try those on your own because, like I said, I don't want this video to be 2 hours. All right, so here we have, it says the following are the number emails random people receive on a given day. So we're going to describe the data, meaning, you know, what is the shape, what is the center of the data, what is the spread of the data, and what are the outliers, if any. So I want all of you to work on this. And then when we have our, what's it called, Zoom meeting this week, I want you guys to tell me what you figured out. So let's go ahead and say, I haven't scheduled it yet, but let's go ahead and say our Zoom meeting will be Thursday, the 21st at 1 o'clock. Okay. So I want to discuss this particular problem with you. And also your Zoom meetings are for, if you guys have problems, that's when you bring it to me. Okay. All right, you guys, did you hit your learning target today? Can you describe data by its shape, the center, the spread, and the outliers? I hope so. All right, if you guys need me through the week, let me know. Friday, you're doing a little puzzle. You're practicing making a box and whisker plots. And then you're going to send me, you're going to take a picture of your paper and you're going to send that to me for your grade on Friday. All right, you guys, y'all have a great week and I will talk to you guys soon. See you later.